So today's virtual panel is focused on the workforce development issues of the microelectronics industry, but this one we're going to, have as a flavor to the conversation that which is focused on heterogeneous integration and packaging. There are other panels focused on other important topical areas in the microelectronics industry. Today, the guiding light will be those that are relevant to that area. Why are we here? I think, largely we're being inspired to stand up and work together to take advantage of a once-in-a-lifetime opportunity to really, scale up and improve the workforce development done here in the United States in particular to support the growing microelectronics industry that is going to be driven by the CHIPS Act and other efforts to reshore or onshore, repatriate the industry. So the challenge that we have with this workforce development in some areas across the nation is a bit of a chicken and the egg challenge. This is a challenge in terms of what's coming first, the jobs or the workforce, right? So let's look at that. Growing the workforce I call these next tier states, and I'll show you an example of it, is areas where we have maybe historically had fewer jobs and the career potential is not maybe as appreciated by the population there. And, the programs that might exist aren't really set up for that because the industry is not quite there. So the companies struggle to meet hiring needs in state, and they can bring in out-of-state talent, but sometimes, across the nation in different areas, that could be a challenge. And so, this is often an issue. It can be an issue in places like Florida, but I think there's great opportunities and great need to have this be a nationwide workforce development enhancement and not necessarily be dependent on just localizing in a few places. Today, we're very fortunate to have several panelists join us today. You see them here. We've got Todd Youngkin from SRC, Najmeh Ibrahimi from UF, and Kevin Huppengarner from Renaissance, Lee Orlando from ANSYS, and Eric Breckenfeld from SIA, and finally Walter Koken from the Global Foundries. And I'll just briefly introduce each one. I don't have a slide to introduce myself. My name is Jack Judy. I'm a professor of electrical and computer engineering here at the University of Florida. I run the Nanoscience Institute for Medical and Engineering Technology. I've taught courses in microfabrication for decades and have a passion for that topic, and I'm happy to be the moderator for today's session. So Todd is the president and CEO of SRC, where he leads a $100 million research agenda supported by thousands of researchers across the nation, if not the world, and including 27 companies, a bunch of government agencies, et cetera. And prior to going to the SRC, he worked at Intel for nearly 2 decades and had all kinds of research and development experience in the technology nodes spanning from 180 nanometers down to 5 nanometers. So we're very fortunate to have Todd here. He's also very passionate about workforce development components that are critical to the success of the industry and SRC's involvement in supporting that. Najmeh is an assistant professor here at the University of Florida. Her research focuses on millimeter wave and terahertz scalable arrays for high data rate wireless communications. And she's also very interested in the security and connectivity of Internet of Things networks. She had her postdoc at Michigan in 2017 into 20 and got her PhD from UC San Diego back in 2017. She's doing extremely well. She's been recognized as a rising star by multiple organizations, including, MIT's EECS Rising Star Program, as well as the ISSCC's Rising Star Program. And she's also notably the recipient of a DARPA YFA. So congratulations, Najmeh, and we're happy to have you as part of this. Next up is Kevin. Kevin is the Senior Director for Renaissance America in Palm Bay, Florida. He has decades of experience in the semiconductor industry, where he worked across multiple different organizations in this area, including Texas Instruments, L3Harris, Intersil, and of course now Renaissance. He has a background in wafer fabrication, process development, yield management, all the operations associated with production of microelectronic components. And currently at the Palm Bay facility, he's responsible for managing the facilities, wafer fab, reliability probe, assembly, just lots and lots of that. So, and I know he's seeking to grow that and has got keen interest in workforce development. Next up, we have Lee Orlando. So Lee is at ANSYS, and he joined very recently, I see in January of this year. Prior to that, he spent 21 years in the Air Force Research Laboratory in their sensor directorate. And he's actually been a major leader of their workforce modernization of the workforce area. So he's got keen interest in the workforce discipline, and has also provided a lot of leadership in the area to strategize training and that are relevant to missions in the military, and to figure out the proper ways to insert technologies and intelligently make decisions across the whole defense, at least in the Air Force lifecycle. And he's done a lot in the area of recruitment and retention and upskilling to address their needs. And now he's bringing this to the microelectronics industry more broadly. So we're very happy to have Lee as part of this as well. And finally, we have Walter. Walter started off at IBM as a process engineer, but worked his way up to became a division capital manager and had several management positions in process development as well as semiconductor manufacturing at IBM. He's currently at Global Foundries and leads their 3D heterogeneous integration and development efforts across the fabs, highly relevant to today's conversation, and we very much look forward to his input. Actually, sorry, we have Eric here, who is the director of technology policy at the Semiconductor Industry Association, SIA. He leads their research and development activities and also with their education and workforce development. So again, another person passionate about this topic. Prior to joining SIA, he was a lead scientist at Booz Allen, where he engaged predominantly with various defense clients like DARPA and others. And before Booz Allen, he was actually a AAAS Science and Technology Policy Fellow with the White House, specifically on their National Nanotechnology Initiative. So that's a unique perspective. And he's also been a research fellow and at the Naval Research Laboratory, and has a deep passion for STEM education. So we have a great set of panelists. This was, the slide that I had that talked about, we want to grow this workforce, not just in the, a few states like California and Texas and Oregon. I think there's opportunities. I'm a little biased. I highlighted Florida there. I feel like very few people know that Florida's 5th in this ranking in terms of workforce. And there's opportunities for Florida, Idaho, Massachusetts, New York, and others to grow. And we need to improve our workforce development components in those areas to grow it locally. I think to do so is going to require teaming, and we may get into that a bit today. And when we talk about some of the opportunities and challenges, the teaming between industry, between the states, and between the various training organizations like universities and colleges. There's a great need to coordinate that to be very efficient and effective, and perhaps some of those topics will come up today. So I'm going to go ahead and just say, we also have a common challenge. We have to increase the trainee population coming into our field. We have to think about things like, frankly, persuading them to choose choose our career pathway instead of alternatives that are very enticing. We need to scale up programs so that when we can entice these students at the K-12 area to get in this area to be able to have programs in their area locally to join and grow. And so, these are common challenges that I think that need to be addressed. I also have, any efforts across these different states are going to need to work with different state level stakeholders. There's going to be stakeholders focused on industry support and trainee support and others. So, that's an important area. And I have some seed questions here that I'll save for later, but I think I'll go ahead and stop my introductions and then let the panelists give brief introductions of themselves. So that's it for a quick overview. And I guess I'll go ahead and start with Todd. Todd, do you want to kick us off here with a few comments? You're welcome to share some slides about this topic area.
Sure. Yeah, thank you very much for having me. And I'll share a couple slides that are dense because as an engineer, I don't know how to make slides that are not dense. But they're really meant to be a reference for the audience to dig into later. So I'm the CEO of SRC, only the third in its 41-year history. And I really am proud to work for an organization that basically has this starting point, right? We need to fund more research and more people associated with the semiconductor industry. And this is chip making and packaging at its heart. And we get a lot of good questions about what it means to be a semiconductor industry a contributor and to educate. And one of the things that's really important is it is a very multidisciplinary space. And depending on the sector that you go into, be it fabless, defense, foundries, materials, there are different mixtures of education levels and disciplines. So we invite you to this blog to see that essentially it's electrical engineers, a lot of material scientists and chemists, physics, and of course, some computer scientists. At its heart, when SIA and SRC put out the SIA blueprint and the decadal plan calling for a 3x increased investment in semiconductors, that was also meant to be 3x more investment in the educational pipeline. But I would say that our members, our ecosystem is asking for 5x more materials and mechanical engineering. So ECE needs to grow, but the materials and the process folks need to grow at almost 2x the required pace. So we're all, of course, very excited about this once-in-a-generation opportunity. SRC is pursuing a Manufacturing USA Institute and workforce development, and then doing what it can to partner with those that are putting forward initiatives in the NSTC and the NAPMP. And of course, we're all really excited that the and science portion eventually gets some funds behind that authorization and grow in ways beyond what the CHIPS Act will formally support. Our plan for the decade is really to go from the what in systems to the how in chips and packaging to implementation through a Manufacturing USA Institute. And maybe the key point here is that we just put out the interim roadmap that includes a workforce development chapter 7. So please look for that. We are now building our Manufacturing USA Institute proposal, and if anyone in this audience would like to join us as a plan supporter of that proposal, please don't be shy. But beyond the technology ambitions, the reasons I'm here excited to talk today is because the people, the workforce crisis, the support for the humans, the technologists actually exceeds our need to reinvest in the technology. And so please look into our broadening participation pledge and the implications for heterogeneous integration and advanced packaging. And please don't be shy. If you ever have any questions of us, we're here to serve.
Excellent. Thank you very much, Todd, for that very efficient, like a good engineer's introduction. Very dense, but information rich. Excellent. I'd now welcome Najme. Are you able to join? And thank you so much. I know you're feeling a little bit under the weather, but we really appreciate your joining us.
Thank you. Sure.
Slides.
Yeah. Hi, everyone. Thank you for inviting me. I'm going to briefly, can you see my screen?
Yeah, you can go into presenter mode if you want.
Sure. So my research is mainly for I make chips for next generation of wireless communication, namely 6G and above 100 gigahertz. And why I need packaging? Why packaging is very important for us, because previously, like 10 years ago, students in my area, they just care about making the chips. Like 10 or 20 years ago, we only care about how we make these discrete components on the chip in a miniaturized and small area. Now we need to put more chips and antenna packaged. and the 3D or 2D integration. We are moving toward 3D integrations of the chip and antenna, that we can have easily scalable, more antenna, more channels, and cover more data rate, more link budget for the next generation of wireless communication. So therefore, excuse me, the integration of the chips and antenna, and also sending and the synchronization data or the I/O data between the chips are going to be very important for us. So we are, as we are moving to the 3D integration, then the collaboration between the academia, the chip industry, and the packaging industry are going to be important, because we are moving to the choosing the best junction of the function, meaning that if, for example, for some application like the power amplifier, low noise amplifier, one semiconductor technology is important, such as 3.5, maybe for modulation or for baseband, another technology like CMOS or silicon germanium are going to be important. So first, the semiconductor industry are going to be very important to choose, as I said, the best introduction of the function, and also we seek for the technology to integrate them to 3D heterogeneously integrate all these different technology together. Unfortunately, in the US, there is a big hole, there is a big lack of collaboration, information, that how we can make them integrated. As of today, I'm talking to you, we still don't have any solution, any straightforward solution, how we can make this 3D integration happening. So if I can show you this, the top part showing the flow of the chip industry. So for the chip industry from 20 years ago, like GF, TSMC, or other vendors, they provided us a very good CAD tools that has been improved through the years. And you have access to these tools to have a very good and accurate chip design. So you can design whatever you want and have lots of iteration, trial and errors to make your chip finally works, and then test them. Unfortunately, for packaging, we don't have that straightforward solution, because it needs different information, not just on the chip side, also on the packaging side. We have the tools, but we don't have any information what's going on with the interconnection, with the substrate, and when we put them together, we don't have any good estimation. That's what we have to expect to receive. So therefore, how I care about this area is that first, standardization, characterization, and we really need to have a good solution for this next generation of the 3D integration, where you have to put the different semiconductor material and different substrate to make an scalable array or any other function you need.
Okay.
Thank you. Sure.
That's wonderful. Thank you. Yeah, you're dealing with these challenges head on. Your research is very exciting. Thank you. Next up, I'll ask Kevin. Can you give a brief introduction to yourself, or really your perspective on this? There you
go. Jack, let me go ahead and share my screen. Can you see how I'll go into presentation mode?
Yes.
Can you see it? Okay, great. Sure. So thanks, first of all, for having me here and being able to talk a little bit about our operation, but moreover about the needs of not only our operation, but the ongoing semiconductor needs for both the Southeast as well as the U.S. in general. We've talked a little bit about over the course of some of the discussions how we've seen this this offshoring which has occurred over the last 1, 2, 3 decades, and we've seen our industry really leave. So I'm really excited about the bringing those opportunities back on shore. And we talk about what's going to happen in the future, and I still want to just focus a little bit on that. We have ongoing needs right now here in the U.S. And what I'm depicting here is the current ongoing operation that we have here in Palm Bay, Florida, with Renaissance. We have a site which is a little under 120 acres and 380 employees. On this site, we have all the things that you would expect in a fully functional, company or corporation, including marketing, sales, applications engineering, product and test engineering, along with, typical business, finance folks and things like that. But specifically to, what we're talking about here today, we also have a fully operational wafer fab, which runs on a 24/7 basis, here depicted on the right-hand side of the screen. And then on the left-hand side, fully functional probe assembly and test, which is focused on high-rel space applications. So as was mentioned earlier, I think Todd talked about, all of these different disciplines which are needed, which includes mechanical engineering, chemical engineering, material science engineering, electrical engineering. And when you look at an operation like mine, I have all those needs on any given day. I'm always looking for roles to be able for folks to fill those roles. And if we back it up even further than that, even at the operator level or the maintenance technician level. So we have a huge skills gap right now because of this offshoring, which I mentioned earlier, which has occurred. So we don't see this large pipeline or funnel because we just, as a society, don't recognize the need, which has been here at a low level. But I think with the CHIPS Act monies, coming forward, it's really starting to highlight that. So it is an opportunity for us for the first time in a very long time to really bring relevance to our industry and the ongoing need, which is certainly there, and is going to continue to be there. All right. Thank you.
Great. Thank you so much, Kevin. You can stop sharing. That, I'll have to come down and visit. It's not that far away from me.
We'd love to have you.
Awesome. All right. Next up, I guess, the hub Lee. Is Lee, there you are. Go ahead and share the screen if you'd like, or just make some verbal comments.
Yeah. So good morning. I'm Leonard Lanto. As you mentioned, my experience has been fairly broad, coming from both the Air Force side and now with a commercial company, ANSYS. What I would like to highlight is in my past experience, my observations have been really around the fact that a lot of effort and focus has been in our community to perform high quality research with the intent that the scholarships and grants that are provided at these levels would draw in the student body that we would need to perform that type of research. Well, unfortunately, that hasn't built enough capacity in the pipeline. The pipeline is not broad enough, even at the K through 12 level, to draw in those students to do that high quality research. And specifically for the defense industry, having those that are clearable into U.S. citizens that are clearable into those facilities ends up being an additional challenge on top of that. And I think the intent of what we're trying to achieve at those different levels, K through 12, for instance, is really to develop reasoning and soft skills and expose them to the challenges that exist within our community. Just even that microelectronics exist is a good place to start. In comparison to someone like the cyber industry, who's done a very good job of promoting and marketing that there are challenges that they should be aware of, even at a very young age, has drawn them into those more software-based skill sets, unlike the microelectronics industry. The other thing we often do is we focus on those exquisite expertise where it might be a 1 to 4 or 1 to 5 ratio of support staff and others that are supporting the engineering talent that are building the next microelectronics components, but aren't addressing the other skills gaps that we have in terms of drivers that might be moving materials around, or some of the more logistical, legal and contracting aspects of our ecosystem. So I just want to kind of throw that out there because I think there are opportunities at the community college and trade school level, as well as the higher education levels, to complement the semiconductor industry. And I think that's even more readily apparent probably in the packaging area, the board and packaging area, and could extend into the heterogeneous integration. Now, taking a step back and looking at it from an ANSYS perspective, our job is really technology enablers. So what we're doing is we're taking a lot of that engineering knowledge and embedding that within our software to allow people to operate in a virtual domain in a much faster way. And so we are still looking for that exquisite talent, but at the same time, we're enabling those others to achieve the things they should be doing, or focus on the technical challenge and not the more mundane tasks. And so with that, we already have a good set of curriculum because we have to train our users to be successful. And I would advocate for industry participation in that area. And then one last point I'll make is that learning is a continuous process, and it requires industry engagement. industry needs to be part of that conversation and continue to promote the needs that they have throughout that pipeline, so that we're meeting those needs at those various stages, K through 12, community college, and up to the university level. So I think this is going to be a very interesting topic of discussion for this morning.
Thank you, Leonard, for those wise words. I think I saw a lot of heads nodding up and down. So we look forward to engaging you and the audience with a discussion on those topics. Last up is Walter. Walter, I see you're on. I don't see a video, but you're welcome to share that if you'd like.
Can you see my screen right now?
I think there it is. Yes, I do.
Okay, I just quickly, a little bit of a introduction to Global Foundries, and specifically, I lead the 3D heterogeneous integration effort at Global Foundries, and I can tell you one thing, that the phone doesn't stop ringing anymore, whereas maybe it was more of a skunk project 3-4 years ago. So it emphasizes how important the heterogeneous integration is becoming to the industry and to the extension of the Moore's Law. Just maybe a quick introduction chart here on how foundational the semiconductors are. And obviously we heard a lot last year about the shortage, but there are really only 5 big foundries at scale. Global Foundries is one of them. And 3 of them being really in China and Taiwan. And when I call it scale, with over 5 billion in revenue, but that is really foundational to this $602 billion of the semiconductors that leads to $2.24 trillion of electronics, and finally $92 trillion of GDP. So we're at the bottom of that foundation, and enabling all of that GDP. Somehow my screen is now moving forward. Let me just quickly. Okay. Obviously, I mentioned delivering a new era of more through heterogeneous integration, but also what Global Foundries is doing is really more innovation in the silicon and 3-5 material technologies. We all are very familiar with the new mega trends shaping our global economy, looking at AR and VR, also artificial intelligence and machine learning, and finally data everywhere. And those mega trends are really accelerated or limited by semiconductors, as we heard a lot last year. We are, as Global Foundries, positioned uniquely in those markets that really matter. You probably can't find a cell phone, no matter where you go in the world, without Global Foundries silicon content in it. And finally, we're very engaged in those very hot trends as far as home, industrial IoT, automotive. And then finally, our RF division is really huge as far as our revenue. And we see that SAM growing all the way up to $25 billion by 2030. What's also important to this discussion is that Global Foundries created what's called GF Labs, where we do a lot of innovative research with universities like University of Florida and many other universities that are involved. That really allows this very close connection of the professors and students, and sort of for us, not only builds the research pipeline and future product pipeline, but also the student pipeline, if you will. And just very quickly, we have really 5 big fabs, 4 big fabs, and then recently announced a fab jointly with Incro's friends. But essentially, it's a mid-sized company, about 15,000 employees, Last year's revenue actually grew to over $8 billion, but you can see that Malta is, in the US, we have a fab in Malta, being a mega fab. And then in the state of Vermont, we have a fab in Burlington. And then we are highly positioned all over the world because we also in Europe have a mega fab in Dresden. And finally, a very huge, actually a multi-fab in Singapore. Okay. We were also listed on NASDAQ last year, and probably one of the few semiconductor companies that is actually up 40% since the stock market started going down in November of 21. Very quickly, we're heavily involved, besides heterogeneous integration, that actually crosses all of these areas that we're involved in. We produce feature-rich CMOS technology. We have very advanced FinFET technology. We have fully depleted SOI FDX technology. RF SOI is really huge and big part of our portfolio. Finally, we've been publishing lately a lot on our silicon photonics technology, and we're getting, along with SiGe, and getting very heavily into GaN and 3.5 materials. So innovation beyond transistor size, innovation in heterogeneous integration that I'm representing here. And finally, I think what's key to this discussion, both of our fabricators in the US are heavily involved in the government production and projects. So we always seek the technical feasibility, look at the US government needs that have been obviously heavily published with this act and new money that's going to be available. And then we try to find the perfect intersection between our commercial business, US government needs, and technical innovation. Okay. So long-term relationship with the US government is a great leverage to keep creating this technical innovation. And just as the final page, we're pretty present there in the social media, and here are some of the links.
Okay, great, thank you. Hopefully we'll have discussions about workforce issues associated with all those exciting opportunities you've described.
Absolutely.
You can stop sharing your screen and we'll go back. So at this stage, the audience has met everyone, and we have a great panel, and I'd like to open this up to the audience if they have some. Oh, I'm sorry,
Jack. I'll just interrupt. I think we've
met.
Eric, we've missed one, sadly.
Yes, sadly we did. My bad. I'm sorry, Eric.
I can go quickly. I promise. Somehow quickly while showing a slide deck that you'll say, boy, it sure looks like it says 6 slides in the corner there. But we'll go quite quickly here. Here we go. Share. Is that coming through? Okay.
Yeah, it looks great.
All right, fantastic. So. You know, we've heard a lot of great info about, you know, what's part of this heterogeneous integration advanced packaging need, in a sense, what's part of the plan. And we heard some great info from Todd up at the beginning, you know, in a sense, how can CHIPS Act go help pursue this? You know, I just want to note heterogeneous integration advanced packaging, the global center of gravity of that is not determined yet because it's very new. The US has a great shot at becoming one of those global centers of gravity of innovation and advanced packaging, and then more specifically for heterogeneous integration. The CHIPS Act can help with that in a few specific ways that I'm going to go into, and then maybe have a little bit of a info share at the very end, and perhaps not quite the same call to action that Todd had, but definitely reach out to them if you want to get involved with this Manufacturing USA. I'll give them another plug there. So very quickly, what is the CHIPS Act? You know, we hear it's $52 billion. I wanted to just do a level set. What's in that $52 billion? All of it, in a sense, can touch on workforce, but there is $39 billion set for direct incentives to help go stand up additional, you know, more global foundries, fabs, perhaps more packaging as well. We're still waiting to hear about that. But there's also this $13 billion, which is for R&D and workforce investment a lot more directly. That's the pot of money that these Manufacturing USA institutes are coming out of. let's go talk very briefly about what's that 13 billion. I'm going to zero in on that. What's that going to go towards, and how's it going to help us address these things that we just talked about? So $13 billion, CHIPS Act, R&D. It splits into, this is a dense slide, I know. We'll just try to hit the big areas. Splits into 4 areas, really. There's this $2 billion that's going to go to this CHIPS Defense Fund. This is for this idea of a DoD Commons. That request for solutions closed in February, so there's not so much to say about that until we know where those centers are going to be, but it's going to help set up a pipeline of innovation to manufacturing for DoD applications specifically. The rest of the 11 billion is going towards a handful of commerce efforts. One of those is this big idea for a national semiconductor technology center to focus on perhaps both core semiconductor technologies and maybe packaging as well. That remains to be seen. There's going to be a lot of workforce development involved in this effort, and a lot of money is going to go there. Commerce is going to be releasing a white paper this month to explain what the priorities regarding that are and how they want to proceed. I have a timeline at the bottom here that talks about how clarity on these efforts is going to go forwards. There's also this idea for a national advanced packaging manufacturing program. Probably going to have to wait till later in the summer or the fall to learn more about that, but it's going to be very impactful for the heterogeneous integration and advanced packaging side of things, and it's intended to include quite a lot of the workforce development efforts as well. And then finally, as Todd already mentioned, there's these Manufacturing USA Semiconductor Institutes. We don't know quite how many yet. We know that packaging is going to be at the center of at least one of those, and this is what SRC is involved in. And when I know, when we say workforce development, we need to be clear that there's CHIPS Act support to go stand up this infrastructure, but the workforce needs to be there as well to do it successfully. We've heard about that already. What do we mean by workforce? Of course, we mean skilled technicians who can interface with a lot of the equipment here. We need materials and equipment folks. We're also going to need design. Design will be a big part of heterogeneous integration, and that will need to bring forward companies who have design excellence, but can focus it in a way that can shall we say, give access to the types of players that are going to be playing in these sorts of ecosystems. So again, this is sort of the timeline at the bottom. We're going to get a lot of clarity over the next 4 or 5 months about all of these efforts. So I would say stay tuned, and please don't hesitate to get in touch with me if you want to know anything else. We can kind of cut this slide. I already talked about a lot of it, but there's workforce impact on all these areas. All those institutes we just talked about are going to have some pretty strong workforce component. And there's also 200 million to NSF over 5 years to go pursue workforce more directly. I will conclude by saying we have a map that has gone live on our website, semiconductors.org, tracking not only new facilities as they're announced, but the footprint of the industry and even those universities that are especially plugged in to pursuing this space. So you'll notice the University of Florida is, of course, on there. Kevin, you'll note if you're tracking the dots, Renaissance is down there as well. I haven't highlighted them. But every time new projects get announced, it gets populated on here. I would urge you to go take a look. You can sort by facility, you can sort by industry segment. If you notice things that are missing, please don't hesitate to get in touch with us and tell us, hey, this ought to be on there. I'll note, Jack, you mentioned Florida's 5th in employment in this sector, but nobody seems to know that. I'll tell you, you're exactly correct. Not only does nobody know it, but Florida senators and representatives, when I get the chance to talk to them about CHIPS Act, they say, well, the CHIPS Act doesn't really affect Florida. We don't really have any semiconductor jobs. And I'll tell you, it's as much your fault as it is our fault. We all need to do a better job of educating them and saying, hey, this is in your backyard. Your constituents are the employees of these industries. And if we have anything to say about it, that is only going to grow. So we do need to know about that. So I'll end there, and no longer prevent us from getting to the discussion.
Awesome. Thank you, Eric. That was fantastic. I hope the audience is as energized as I am by all the discussion and ideas and opportunities and challenges that have been articulated thus far. Again, at this stage, I really would like to open this up to the audience, although I do have seed questions I'm happy to put out there, but I welcome the audience to chime in. So let's see how we're going to do this here. Do we have, I guess we have Harry, is it the best way to do this with the chat or the?
Probably. We do have a question in the chat right now.
Right. Okay. So hey, we have a question here. How can companies and educational institutions address the potential impacts of automation and artificial intelligence on the workforce, and again, specifically on heterogeneous integration and packaging? Great question. So I know this, I'm at the university and I'm trying to devise strategies to increase the human workforce, but there's also a tension with automation. So I open it to the panel. So go ahead.
Yeah, I have a comment on that, Jack, and it's very fortunate that we're being hosted by Florida here. Florida and NVIDIA have an active partnership to stand up AI and computing resources and get educational institutions access to them. So that resource is being stood up at the University of Florida. But as I understand it, the plan is to grant access to partner universities, community colleges. This is a partnership that is intended to help get AI interfacing and machine intelligence interfacing skills to students. I think that's the kind of thing you have to start with, because you're exactly right. Getting familiarity with automation and artificial intelligence tools is the sort of thing we don't want PhD scientists and engineers to be the only ones who know how to do this. We need to percolate those skills down, even down to the associates level, where they don't need to understand the fine details of how it works at the model level. They need to know how to work with it. And, you know, as we go to stand up heterogeneous integration, this is a new pipeline we're standing up. I think that's a great example of an area where we can prove out getting those skills to those people, and especially because there's funding with the CHIPS Act to support those programs. So I think it's a great opportunity. I don't have a curriculum answer for you, but I think, you know, Florida's a great example. I think a lot of the pieces are in place to go and pursue that. And really it's a question of executing on the vision, and, you know, visions aren't always so hard to find. Funding can be hard to find. We have vision and funding. And so that the time now is to execute on that. And I think Florida's a well-positioned ecosystem.
Thank you, Eric.
Yeah, if I can, yeah, I was just going to jump in and kind of piggyback off of what Eric was saying. What I see is actually a shift in skills, right? So you have those that are developing the AI engines, that are training the AI engines, but then you have to have the technicians and users of those AI engines to apply them appropriately. So we kind of saw this in the car industry, the automotive industry, as more automation came into play. There was opportunities for community colleges and others to participate at a technician level, where they're using the automation, they're programming the tooling to do the jobs they're supposed to be doing. Now, that does shift you from a manual labor perspective, but it doesn't necessarily remove the human from that engagement at all. So there's a shift in the mindset that has to go on throughout this process of adopting AI and machine learning tools. Because they're very good tools in terms of the inspection and analysis, but they still need the bounding of the human in that loop.
Thank you, Leonard. Any other panelists would like to chime in?
I would bring it down to even a lower level. So we've established the first in a country, as far as I know, apprenticeship for semiconductors in our center of gravity, which is Malta, New York, where you can essentially get a pipeline of high school students that don't even need a 2-year degree to essentially learn about semiconductors. And this could be one of those trainings our fabs desperately need in the technicians, would be how to deploy AI in those tasks that we just can't hire enough people in the fab to do them, and to be as good as AI would be able to do it in the future.
Thank you. I'd like to ask a follow-up question. I think we can all see the future with automation and AI, but the status now and in the next year, to what degree is automation and AI going to play a role? Because I mean, a lot of this has got to go into, like, I imagine, the tools and the software, and that takes time to implement. So we have issues now that we need to address, but we have to protect these people to get the training so they have a little more future career proofness. But I guess I wanted to get a sense of timeline from folks on this issue. It helps people plan workforce development in this area too.
Yeah, so I'll jump in real fast. So I see two things. The first is you have the near-term workforce needs, and that could be supplemented either through green card holders or a more international body, and the application of AI and machine learning. Then you have the workforce of the future. That's going to be a much harder and long-term approach that has to be implemented to draw those individuals into the pipeline and train them appropriately. So it really is a combination of those two aspects that have to be taken into consideration when we're talking about the workforce needs of today and of the future, because they are quite daunting.
Thank you,
And
Tom.
maybe I'll piggyback on that. I think Eric said it nicely that part of what the CHIPS Act's trying to do is governments can help shine a spotlight on what's important and then assist in where it's located. And then the universities can help ensure that we have the right ideas and the right people moving to meet that moment in time. So when we look at packaging as a whole, it's been offshored for a good number of years. Universities have been told this topic is not interesting, it's not academic. The students are given that same signal, right? So part of the automation challenge and opportunity is that we know we have a cost of living difference relative to other locations, and any facilities we build here need to be advanced, they need to be automated, and they're going to be highly complex. So the people that are going to staff that facility will need the requisite skills. And I think if we keep that in mind, if we build a digital twin that has the world of mesoscale packaging and integration and is really interesting rather than a Ready Player One landscape based on Fortnite, I think we'll win hearts and minds.
Thank you. I might also suggest that even in this future where we have extreme automation, we're going to need a lot of folks to support that, right? Maybe the people aren't driving the rivets, but they're maintaining the robotics, they're programming it, and so it's just an adjustment. And so
it's a different skill set, but it's going to be a highly compensated job to maintain and deploy those robots.
Yeah, the value impact they can have being excellent in that area is substantial.
Yeah, and I wouldn't, Jack, I wouldn't look at, and this is going to be true beyond just the semiconductor industry, but I think just because we're a relatively high margin product, we may be the first to pursue some of this. These automated tools are not there to replace people. They're there to make our workers more powerful, because the technical need is that we need more powerful workers. And the truth is, for heterogeneous integration, we're not going to go in 1 year. 2024 is not going to be the year that heterogeneous integration is the biggest value add part of this industry. It's going to move in that direction over many years. It's not even the biggest part of the CHIPS Act, which is fine because it's not the most expensive thing the CHIPS Act is trying to do. But on a 10-year timeline, it may very well be one of the highest value add things the CHIPS Act pursues. But that's going to take time because, the workforce isn't there, the tools aren't there, not on a very large scale, which is what we'd like to be doing this with. So I think you're seeing a lot of this right now, at the DARPA level, at the academia level. There's a lot of great stuff in the pipeline. I know there's a DARPA program, NGMM, that's proceeding right now into a phase 0, which is pursuing this idea of specialized 3D heterogeneous integration and advanced packaging. So it's going to roll out in sort of fits and starts. Some of those will go train the workforce, because you train the workforce by doing research programs at times, but some of it's going to need to be a lot more deliberate, right? So the technician side will not automatically get trained just because we're doing all these research projects. I think that's the area where you need to come in and form those partnerships to make sure those skills are percolating in, right? And the good news, again, is that there is funding in the CHIPS Act to go do that. It's now on us to go form those partnerships and make sure access to those tools is part of it.
And on the technician skill, very good point made, because I would say if I look across our fabs, around 40 to 50% are still technicians, and the best, and it's really hard to find semiconductor curriculum, right? So partnering with 2-year colleges is a great pipeline, and creating those semiconductor curriculum is a great pipeline for this industry and heterogeneous integration. This is something that we specifically also done around the Malta, New York area. in addition to the apprenticeship, where you can get a technician trained without a formal 2-year degree straight out of high school.
Yeah, thank you. Yeah, this was a great discussion. I feel like I want to have one quick question, was that the heterogeneous integration is heterogeneous, and by definition, it's more diverse. And thus it makes me think that the leader in our industry in terms of automation is probably going to come from the non-heterogeneous arena. Do you agree with that? And that the heterogeneous side will benefit and leverage and adapt that, but given the diversity of materials, and or is that not really true, that both are going to go in parallel? There's a demand and need for automation now, and there's no sense in waiting.
Yeah, I can jump in on that one, at least very briefly. I think that heterogeneous integration, at least in the near term, has to follow to some extent, just because it doesn't have that center of gravity to drive the conversation forward on its own, right? So I think a lot of those tools will be developed for, let's say, parallel applications. But I do think over time, the value add of the heterogeneous approach will become a bigger part of that picture. So that's why I would say in the short term, yes, I do think so. I think in the medium to long term, it may be a different story. And frankly, some of that will be determined when you talk about heterogeneous integration and the diversity of chips there, you're also having a conversation about access. So who are we allowing to play in this space? What kinds of IP can they get access to? What kind, if it's a chiplet approach, does this all live in-house in one of the big companies, or is it more broadly accessible? Those are questions we still need to answer. And I think, there's CHIPS Act, again, I maybe will sound like a broken record on this. There's CHIPS Act funding to go try to answer that and say, yes, we do want it to be more broadly open to medium companies, to startups, to small design houses within larger companies, things like that. And that may drive this greater diversity that actually starts to become dominant down the road. That's how I would look at it.
Very good. Let's thank you. Let's move on to another question. We have one that is curious about, collaboration between industry and academia is key to a sustainable workforce. That's been mentioned a number of times. The questioner is wondering what might be some of the best ways to achieve that, to collaborate. What roles can industry play, and how can we team effectively? Is there any insight into?
Yeah, I can jump in here for this part. So I think the most important things for academia when we train students like the undergrad or in grad level is that licensing, accessing the technology. I mean, 10 years ago when I started my undergrad, I accessed to the 180 nanometer technology node, and after 10 years, still students access to the same technology node. So the technology are getting advanced, but at university level, we cannot provide that access to undergrad level. So the licensing could be very expensive. And so a collaboration between these semiconductor companies, GF, TSMC, or the Cadence, that we can train more students, that the access to the technology is going to be easier, or more the students can get easily trained by making this procedure easier. It's going to be much better. And also the other thing is testing. The testing, we don't have much facility, even for our PhD students. If we can have access to the lab, or we can provide some internship at the companies that have the testing facilities, that's going to be also very, very easier for us to train students. So I would say, the two things licensing, accessing the technology, and testing facility are going to be the two main parts.
Thank you, Najmi. Do we have Walter?
Yeah, sure. So on that one page that I showed on GF Labs, that's exactly what we envision, creating this collaboration and us giving access to our silicon and most advanced silicon, because we realize the value of the universities and the research that the universities can provide on our IP, on our silicon, and access to our testing facilities and our testing data. So be more than interested talking about that to whoever is interested, so we can create a very interesting pipeline for us as far as future products, but also access for the universities to actual silicon, the much more advanced technologies than just 180 that was mentioned, and heterogeneous integration.
All right, thank you, Walter.
Yeah, Jack, if I could jump
Please.
in.
And then Kevin.
So, yeah, what I've observed is that there is this stress or stressor in the ecosystem between having access to technologies and making them available, right? There doesn't seem to be a common infrastructure that everyone has access to that allows them to operate and perform their research. So oftentimes what happens is you see at the university level, multiple professors that have to come together to basically be able to produce high-level research in the microelectronics industry because of the complexities of digital, analog, and RF, right? And simultaneously have to manage their own unique set of tools because there isn't system administration or other functions that exist there to allow them to operate efficiently. So it really does fall on the burden of the professor to create the ecosystem to train and perform the research of their students. What needs to shift here is that having a common ecosystem in which the intellectual property is available to rapidly produce high quality research and operate in an efficient manner allows the professors to focus on the research and the training and the education of the students versus all these other administrative or low-level tasks. And this is actually, I would say, common in terms of not only the EDA industry, but also in the test infrastructure. You have to have a certain amount of capability for you to operate on. And until that occurs, it becomes very difficult to produce at a high level.
Gotcha. Thanks, Leonard. Kevin, did you want to jump in?
Yeah, I did, Jack. So I wanted to mention, we have to get creative, especially as industry, to work together with the various universities and two-year schools. And we've developed some things which have been very successful. Over the years, like many industry folks have done, is we do internships, of course, with our undergrads, whether it's process engineering, product and test engineering, things of that nature. But we've actually taken it one step further. And 3 years ago, we developed a plan where we were working with the local two-year schools to actually do internships for maintenance techs, for instance. So these are the guys we talked about that are actually in working on the tools, very complex machines, complex interfaces and things like that. And those are skills that when those folks graduate, they don't have. So what we do is we go in there every semester and we're talking with those instructors and we're talking with those students and we're laying out a palette of these are the things that we offer, as a company. These are the skills that you're going to need. This is how it can benefit you in your future. And we get them on board early. And then what we'll do is when they enter the second year of that program, we'll actually bring them on as interns. So we'll do like a 3-month intern, for instance. And if it's successful, meaning they're successful in achieving the things that we need them to, they like us as a company, what we'll do is we'll be very flexible and we'll convert them to a full-time employee effectively, and they'll be working on a part-time basis, which allows them to, interact, finish their school, finish their degree, and we'll give them a bump in pay, which is commensurate with that. And then upon graduation, we would then convert them to a full-time employee, and we'll help them pay for the latter part of that education. So again, we're trying to incentivize and be creative, to get those students and bring them in, as employees. So that's been a program that's been very successful for us.
I want to add one more thing rather than this conventional, traditional way of the internship position. One thing I think is going to be very beneficial is I've seen some of the example is that, the companies has sales manager, sales person, but they also need someone to detect the talents from the classes, how it can work. For example, let me give you an example. So I know some of the university, they work with Qualcomm, Texas Instrument, that they provide some class project, and they select the top 10 students that solve that project in a best manner. And then they provide tape-out opportunity, like they support them, like they can build that chip and they can financially kind of support them. So basically they detect the talents through the classes. So hiring the internship, every student they apply, you don't know what are the best talents. So one of the things I was thinking that maybe in addition to the sale representative, we can also have someone that like have the talent through the classes if they work closely with the teacher, with the instructor. Right now, I'm in my class, I have 70 students, and some of them, they are very interested in the chip design, IC design, but they don't know how to start. They don't know how to reach out to companies to explore more. So I believe if we have provided them those facilities, it's going to be a better day.
Right, thank you. Now,
And Jack, I might just say that as a sort of neutral convener, we have the good luxury of moving past the contract IP money infrastructure discussion to really ask our industry and universities, what's the best way, what's the best problem to solve at that shared junction? I think more conversation needs to be had on both sides of what's the right opportunity for academics and industry, rather than trying to get academics to compete with a 3 nanometer node tape out.
great. Walter, did you want to chime in, or can I make another point?
Go ahead, make another
Okay,
point.
great. So thank you. Yeah, now, we talk about the need to grow the workforce, but, we need to make sure that we're doing so in a very, we need all hands on deck. We need to be very inclusive. And so, I know, Florida is a very diverse state and we're keen to do this, but I guess I'd welcome comments about the prioritization or programs or efforts that folks have had in trying to engage students at minority serving institutions or diverse regions of the country, HBCUs, et cetera. So let's hear some comments about that.
Jack, if you don't mind, since you're talking about minority.
Yeah.
I have a couple of notes I made on the chat. I made a Socratic note there. I hope you guys don't get mad at me. I'm so, every time we talked about this, it's depressing. For those who don't know me, I am an immigrant, I'm Black, and I'm an American citizen. So I'm African and American. I'm not African American. And my wife is African American. I've been with the HBCU for now more than 35 years. I've been in the United States, let's see, I don't know how to calculate, more than 40 years. It's depressing. Let me first, please, this is not a discussion, I'm telling you my experience, so you know. If you don't mind, can I do that?
Sure, let's hear it.
Okay.
You can be brief.
2 things, anytime, and by the way, I know many of you. Jack, we talked not long ago, Surab, Christoph, Kumar. I know Florida has been nice to us and I love to continue working with you. 2 things. Here, how insulting and how demeaning you talk to us. If you are industry, and I've been a chair, I've been associate dean, I've been all director, all of that. If you are industry, you call me Mohammed, do you have give me your best student. Do you know how hurtful it is? It does, what you are saying, I don't care what the student is good at. All what I know, all what I want a Black student from Black university. If you are at MIT, you will say, I want a student who did microelectronics. I want a student who did so-and-so. Okay? Please stop doing that. I'm not talking, if you didn't do it, that's fine, but stop it. Here's the next point. If you are a PWI, Mohammed, I'm writing NSF proposal, and NSF want us to have minority. I'm gonna give you 50K and I'm gonna put your name. Very demeaning. When I went to the same school as you did, I went to a predominantly white institution, very good as that. You can look up and see my production. You can see what I did in my life. What, you think I am in a plantation? You think I'm a slave? I've been through this year after year. I'm about to finish. That's why I want you to please understand that. I want you to pay attention to that. Now, all what you talked about was nothing that has to do with getting more students. You talked about technique, you talk about what is if AI, what is if, and nobody worried about the student. Well, let me tell you something. The student I went to, I was working with and teach, they are very, very unhappy. Very few students will stay. Let me tell you from now. And then you let me know whether I was wrong or not. Very few students would stay in your companies. They will come there, they feel like tight, and they will leave. I know it from my in-laws. My wife is African American. If you are in a school, the same thing. Let me give you two examples and then I will shut up. Example number one, and always I show that to see how hurtful it is. I had a student, one of our best students. He went to an Ivy League. One day at about 10 o'clock or so, he called me crying. Dr. Shwika, I have this signal processing problem, and I've been around asking people to help me. The TA sent me to this, the professor sent me to that. I know the professor do not have to babysit, but this kid is by himself, alone. Why he's calling me at 10 o'clock? Where are you? Where is his advisor? And he's doing a master. Guess what? After he finished master, he left. He came to Howard and he got his PhD. Now, you see, that's one example. Let me give you another example. We had a female student who went to a summer internship. A few weeks later, she called me. She said, Dr. Shwika, I'm bored. I'm bored. They put me in the front desk. They gave you a computer. I'm sitting there. I said, give me the name of your director or supervisor. It happened to be a very nice lady. I told her, ma'am, we follow our student internships. Would you please send me what is he doing? And I want her to write a report after it's finished. A few weeks later, my student called me screaming, Dr. Shwika, what did you do to me? I'm now doing a lot of things. I'm sitting in meetings. I'm really being an engineer, and this is a lot. You stop talking to them, and all of a sudden, otherwise that same student would sit there doing nothing. Now, think about that before you get into this high technology nonsense. So what is the solution? You have to talk to people like me. Maybe I'm too old, but there are people like me. And people who take it. That's why I said I'm an African American. If I was an African American, I'm gonna be honest with you. You all be looking at him as he's the leftist. He's power and so on. You will not understand him. You will put him. That's just the bias, and that's just the racism. And I'm telling you, a person. I've never been a place where they say this is for white only. I've never been hanged. I was in Africa. I was just like everybody else. So don't tell me, oh, this is a talk. I know that how this is my in-law, how they feel. And when you ask them, I'm all right. That's my
Thank you for sharing.
brother-in-law will say. He said, I'm all right. He will not tell you it's all here. I am a professor, I'm old, and I've been stopped many times with the police, and I'm not joking. So what you need to do, you need to talk to the student. You need to really and be honest. Let's meet at the table from the day one. That's all what any answer you are going to answer me now, I heard it and it's bullshit. Don't answer me, just let's move to another place. But please, for the goodness of, and for even United States, treat people, as a matter of fact, you already are making it wrong. You are putting together in DEI, the HBCU, the college, the community college, the Hispanic, they're different. They have different things.
Yep.
So think about that if you are really serious about this.
Okay.
And I'm gonna shut up and I'm just sick,
Mohammed.
still have some problem.
All right, I appreciate that. So I don't know if any panelists want to comment. I know he suggested that we perhaps move on and not necessarily directly answer that. But I think those are powerful messages we should all take home.
I'd just add that I hear his point that the students are individuals, they need support. The support needs, requirements vary across that full pipeline of experience, geography. We see that for the majority students that are at R1 universities as well. So I think a really important point that I would offer in support of what you're saying, Mohammed, is that we need to invest in the next generation of people, and we need to find a way to give them the support that they need. And they're different than the generation that I was in when I was their age. So.
All right, thank you very much. I see some more questions in the chat. It's actually, we kind of touched on this a bit. One is, to what level can certification programs or advanced accelerated skill training programs at a community college level fill some of the workforce needs versus 4-year? I heard that pretty loud and clear. I mean, my experience in engaging with this is that we need a full court press. I mean, we need all of this, right? We need the 2-year, the 4-year, the upskilling, the reskilling. I welcome comments about accelerate. I mean, there's like micro-credentialing, there's just-in-time knowledge. I don't know, there's a lot of different ways to think about this. And so I see Eric, you've unmuted.
Yeah, Jack, it can be a great way of going about it. I'll just point at some examples of successful programs that I think, Ohio as an example would like to scale. And that's not the scale program, although that's a great program too. There's the Maricopa Community College sets of programs that really are focused, have borrowed to some extent from this boot camp idea from the aerospace industry to really get, 2 months, 3 months, can we get someone trained up enough to go work in a fab environment and then continue on the job training? So it's that level. And yes, of course, up at the 4-year and beyond, but I would actually say if you look at the, volume of people, the technician workforce is much bigger, and it's about 4/5 of those that really only need associate's degrees or below, core education, and then the rest is on the job training. And the advantage of that is students that come from materially deprived backgrounds don't have to be sitting in 4 years not getting paid, right? You get someone through a 2-month or a 3-month boot camp, they can get on the job training and get paid while that's happening. And so that can unlock huge opportunities for people. And I think that a lot of the scale up you're seeing in places, again, like Ohio, when they look at, Intel looks at, we have all these technicians we need to train. Those are some of the programs they look at, not only because it opens up that aperture to allow more students, a broader diversity of students with different backgrounds to come in. It also is the only way to approach scalability in the short term. They're going to need, this capacity is going to be unlocked over 3-4 years. They need those students getting through a certification program and then getting training now so that they can go operate in 4 years when the construction starts to be done. So I think that's how it's getting looked at. I think that's a huge part. And I would expect by volume of people, that's actually going to be a big part of
Thanks,
how
Eric.
we approach things.
Gotcha. Walter, did you want to chime in?
Yeah, we fully believe in working closely with 2-year community colleges for our technician pipeline. But as I also said, we also believe that we can even get a graduate from high school and sort of in a similar fashion, what Eric mentioned, sort of a bootcamp fashion, we can quickly teach them about semiconductors and what's important, the cleanliness, etc. And the basics of the semiconductors that if they have mechanical or good comprehension skills, they can really start working on these very, very complex semiconductor tooling right away. And that's sort of what, as I said, we kind of started and we're copying that model.
Gotcha. Thank you. I have a question that may relate to some of this. And to what degree do you feel it's what's the relative value of, say, hands-on training, laboratory training versus virtual training, Hands-on is great. I taught that for decades at the university level, but the equipment, of course, they use is crude and old, decades practically. But the fundamental knowledge and insight they gain is still valuable. But I could also see having amazing digital twin, state-of-the-art tool training to be part of that too. So I welcome a comment about that sort of tension, or is it, do we have to do both, or which is more important, et cetera. Go ahead, Todd.
In my mind, it's pretty easy. You need all four tools. You need book education, you need hands-on with rudimentary tools, you need a digital twin that's actually relevant to industrial, and then you need internships to come back and provide experiences to provide that connection between the ivory tower of the university or college and what's going on out there in the really wonderful and exciting real world.
Right. Yeah, I think, yeah, certainly, even if you're doing book or hands-on training, having industrial representatives as part of that, coming by, conveying the, you know, the stories, the value, can really augment the traditional teaching. And and yeah, does anyone else want to comment on that? I see Najmi and Eric. Okay.
Yeah, I think one of the things like the AI can help us here with the virtual reality-based classes. Like, I mean, if you can have a gadget that a student can just put on and see the semiconductor manufacturing procedure, like just learn with this holographic projector-based data, that would one of the things. I mean, I was always thinking that maybe, I mean, in future classes, we don't need like lab. We can just teach them the procedure with this kind of VR things. So I think with the AI and the next technology, that's one of the things I would like to see for the future classes. For the chips fabrication procedure, chip design, they can just see the 3D images and the 3D pictures, like the other application that this VR has.
Okay, I think Eric's next.
Yeah, just to piggyback on exactly that, I think it's a future-looking question. So, what we want in an ideal world, every single student could have a fully functional state-of-the-art fab they could go into and get hands-on experience with. So obviously that's a non-starter. So how do you get as close to that situation as you possibly can? I think the historical way to do it is to get them experience on old tools, because this digital twin and virtual environment was not well built out. Actually, it still isn't well built out. Right. I think the promise of the future is we hope these tools get more sophisticated pretty quickly, and then we can start to supplement this training, hands-on training on old tools with virtual training, digital twin training on state-of-the-art tools without having to put them into a fab. So, I would hope that answer, Jack, has a certain answer today, and then over time it morphs into a slightly different answer. That's what I would hope or expect.
I think, yeah, that sounds like a great answer to me.
Jack, can I just interject here really quick?
Sure.
So I'm in total agreement, and I think the lab component has an additional important factor, which really has nothing to do with the tools. It's really more about the basic processes of problem solving, trying to understand how hands-on interaction with a tool. It doesn't matter what the tool is, because as you mentioned earlier, when they get to industry, the tool is going to be different, right? Those are constantly evolving. But proper observational skills, note-taking, and ability to interact with physical tools and to problem solve, those are very fundamental skills that can be worked on, again, regardless of the tool set. And I think, from my perspective in hiring, if I knew that somebody had those skills, that would trump almost any other knowledge they could come in, at least at the technician level.
I just saw Todd chime in with DOE.
Yeah, I also totally agree with that.
So yeah,
we're in love with the linear invention model, and we got to get past that.
Yeah, just as a personal note, I experienced that early in my academic career, and then made it an integral part of my fabrication course because it was not taught at any other place in the whole curriculum. It's like, how can an electrical engineer graduate and never have seen DOE, and have so I shortened my, anyway. So yes, we need to do better at that. Thank you. We're running low on time, but we still have some more things. I'm not sure where this is going to go, but it relates to going back to the earlier filling the pipe at the elementary school. I'm sorry, but I feel like our industry is doing a very poor job at marketing itself, at increasing awareness, and meeting the next generation where they're at and what their priorities are. We can't force them to take these jobs. We need to be relevant. And so, how do we do that? Right? Is a professor going to do that? I don't think so. Is it random intel inside? Is that the marketing campaign that's going to do it? I don't think so. Maybe this is a SRC, SAI, a thing. Maybe it's all of us. So, how do we address that? Because unless we address that inlet to the pipe problem, we're going to be whistling past the graveyard.
Well, for starters, and I might be dating myself here, but I went to for my undergraduate electrical engineering degree, I went to a very large public university, and semiconductor, as an electrical engineer, semiconductor fabrication was really an optional course. And it really changed my life, to be honest, but I could have graduated without ever knowing anything about semiconductor fabrication. And maybe that has changed over the years. Quite honestly, I haven't checked. But that would be my main point from my experience as far as the four-year colleges, especially for engineers, that it becomes part of the curriculum, but also moving it down, trying to excite people about this industry, moving it down to two-year colleges and even somehow into high school education. As for example, my daughter recently took an engineering course in high school, and they never touched on semiconductor manufacturing or fabrication, if you will. And she's in an area where I'm still in the area where there's a big semiconductor fab.
Right, but so this is the thing, we can work as a community to create little modules that get dropped into the educational paradigm. When they're solving a math problem in math, why don't they happen to solve one in the context of a microfabrication standpoint? When they do a science problem, it's not a course on microfabrication, although high school like you have innovatively up there in New York can do that. We can integrate this into more. But I also think we need, this goes to Mohammed's point, we have to understand the students better, where they're at. What are they going to need? They're like, okay, that sounds like an interesting career, but there are these barriers I have with going into that and participating in that. It requires me to travel this other location, or there's some cultural, we have to have greater awareness of that and incorporate that into our marketing campaigns so that they can be successfully attractive to them, and that once they enter, they're supported and feel, frankly, part of what I like to consider the semiconductor family. We need to create a family perspective on this whole industry. There's great job opportunities. The pay is good. The challenge, the intellectual challenge is significant. The teaming opportunity, personal growth, there's a lot there.
So Jack, I'll just note, I was at a meeting with all the leaders and administrators and some of the STEM teachers from a bunch of these STEM magnet high schools recently and across the country. And not a single one of them had any idea what our industry did. They said, oh, you guys are like manufacturing. Is that like welding? And right, they had a circa 1991 car factory in mind when they thought of what our industry looked like. And so, and by the way, we're working, they have an annual meeting out in Phoenix in November, and we're trying to work to get all of them a tour of one of the fabs out there. And so I think it's things like that where when the students want to know about their futures, they talk to, in high school, they talk to their STEM teachers, right? They talk to their counselors there. Those people, the ones the students talk to, have no idea who we are or what we do. And that is our fault. And so at a minimum, those are the people we should be reaching out to. I do think though, Jack, as you noted, how do we interest them? I think that there are a lot of things that, is it still Gen Z in high school? I know there's a new one. Anyways, There are things that they do care about, and we just need to meet them halfway to those things. I think if you ask incoming undergrads, what are they passionate about? They're going to talk about things like clean energy, like sustainability, things like that. At the heart of those, there are computing problems. And at the heart of those computing problems, there are semiconductor problems. And we don't bridge that gap. We don't help them see that. So they think that we're not connected to that at all. Right?
My fear is that we all recognize this, but there's a lot of, who is it one random company going to do this, or is it a consortium, or they don't necessarily have the marketing chops, to get it integrated into these high school or lower program efforts requires teaming with states, and there's 50 of them, right? So
absolutely, it takes a patchwork. It does take a patchwork effort, and that's part of what's so hard.
But I think there's an opportunity here for national leadership, and like you said, if we can find a pathway, hit the STEM teachers, they can then be the champion to facilitate.
You need to deputize people to a certain extent. You're absolutely right.
I want
Mag, if I might, my job interview with the board of SRC was basically this: that we needed to pivot from faster, cheaper, smaller, disposable to tackle the world's insatiable demand and use of semiconductors in all current and forthcoming devices. And the goal is really, if we're going to win the hearts and minds of the next generation of semiconductor innovators, that is what they will lean into. Otherwise, they're going to bio batteries, et cetera, and the funding will pursue wherever folks feel our opportunities and student interest. So the CHIPS Act gives us an opportunity to say, we have some resources. This is an imperative. What do we need to do? We need to stop telling the 2D scaling story forever, and we need to get an attack, a full-on attack for all communications and computation of energy efficient and eco-sustainable manufacturing.
One thing, if I may, I know I'm not a panel. I'm really should shut up. I'm still
We have
sick.
30 seconds.
Yeah, I know. I'm old now. I talk too much. I made an experiment when I was in my school back at Howard and asked the mechanical engineer, why do you want to be a mechanical engineer? Almost all of them told me robotics. They want some, and most of the robotics, if you think about, is computer engineering, is electrical engineer, and yet they all said robotics. It seems that one of the things is to identify some very nice, cute things for the kids, and that and point out that's what we do.
Right, I totally agree. Although I tell you, since 2006 and the iPhone came out, we still stink at it. Right, the whole iPhone, which is it's all chips and electrical engineering and sensors and everything, but everyone just sees apps. Right.
Our board has asked us to do a Big Bang theory TV series on semiconductors for years, and I just don't even know where to start. But I think it's about the public perception, and what we tell our students is important and provides opportunity.
Right. Well, I think we should close this out. I'd like to thank all of the panelists for their excellent responses and insights. I'd like to thank the audience for all of their excellent questions. I mean, yeah, let's just give ourselves a round of applause going around here. I thought this was a really great panel. And I think that, this is not the end, it's the beginning. We have this, to reiterate the final comment, a rare opportunity, once in a generation opportunity to address some of these systemic challenges, whether it's, the engagement of our entire population, changing the mindset, addressing national needs. And it sounds like we're all on the same page, more or less, and that, we recognize challenges. Some we can tackle, some we still need to learn more. But I'm excited to team with all of you to try to tackle that. And I think you're feeling similarly. So thank you all for your time. We'll go ahead and end this conversation. And I welcome, follow-up emails and conversations. I know that everyone, all the panelists here, would similarly welcome engagement with the audience after this event. So let's keep it going. All right. So thanks, everybody. Have a wonderful day and weekend. Good luck with your taxes.
Thank you.